This video tells you the basic properties of inequalities, as you can treat the video as the introduction to inequalities. First of all, before talking the properties, I want to let you know what is the solution of an inequality. Actually, a solution in an inequality is that any numbers that can satisfy the inequalities. So, for examples, in my notes, I tell you that there is an inequality x greater than 5, and you can put in any value such as x is 5, not 5, x is 6, x is 7, 8, and go on. And or you can have any other value, 5.1, 5.2, and so on. So the conclusion is that any number satisfies for the inequality, that the number is the solution of several inequalities. And so you can think that there is many numbers that can satisfy a several inequalities. Yes, so actually, for talking about the solution, actually we want to concern the range of the solution. And so how can we represent the range? And we can follow this method. We can try to use the graphical representation to show the inequalities. And actually, we are 4 types of situations. First of all, x is greater than k. Second case, x is less than k. Okay, just write down greater than, less than. And case 3, greater than or equal to. And finally, this is less than or equal to. And for 4 cases, we have 2 things you can try to memorize for the graphical representation. So first of all, for the direction of arrows, if you know the arrow is pointing to the right, that means greater than. And vice versa, for left hand side, that means less than. And for second case, that is need the equal or not equal, that you can follow my notes in here. If we want to represent the solution that is not equal to, we can use a hollow circle. And for the solid circle, that means the solution should include k. That means your answer should be greater than or equal to or less than or equals to. So if you know the basic ideas about the graphical representations, I can give you some simple examples. Try to consolidate your thinking. So let's move on to example 1. We want to use the variable x to represent the inequality. And here we can split into 2 cases. First of all, if you know that is the left hand side, and you know this is means small, less than. And for second case, that is a hollow circle, so that means this is not less than or equals to. So just simply follow the numbers and write down x is more than 8, and that is the inequality corresponding to the figures. And okay, if we have a following inequality, x is less than 12, then what can we do? So first of all, in the number line, here you can see there is a number line. And then how can we draw our solution, draw our answer, is that we need to point out the position of 12 first. Since obviously we know 12 is greater than 0, then you can put 12 in here first. And then if you know the position of 12, just follow the rules in page 1 of your notes. Since this is not less than or equals to, so we just put a hollow circle. And then for the direction, this is the left hand side, and you know that is the answer. And okay, one more thing, why we should use the method is that actually the solution, that means for the point that the green boxes, all number covered by the green boxes are the solution of this inequality. So we want to use the graphical representation to show our answer more clearly. And okay, so let's move on to some basic properties. As you know, we have some basic method, the graphical representation, to show our answer. But actually, the inequality have some properties we can concern. So first of all, when we add on, we want to tackle some problems about the inequalities. For the addition or the subtraction, we can follow the rules in the equation. Is that there is some names we can reverse to. First of all, we call the transitive properties. That means if A is greater than B, B is greater than C, and obviously you know the result, A is greater than C. So just simple example, 3 is greater than 2, 2 is greater than 1, and then you know 3 is greater than 1, obviously. And the additive property is also simple. Just give you some simple examples. As you know, 3 is greater than 2, 3 plus 4 greater than 2 plus 4, and you know 7 is greater than 6. So for first two properties, you can just try to put in some values and you can try to understand the properties. And for the multiplication, that may be a little bit difficult. For multiplying a positive number, actually the sign remains unchanged. So give you an example in here. If we know 3 is greater than 2, but if we multiply -1 on both sides, oh, I made it wrong. So you may note -2 is actually greater than -3. So we should change our position of the inequality sign, and here you should pay more attention about this. You should change the position, and that is something you really have to concern. And okay, so this is for part B. The example is for property 3, the multiplicative property number part B in here. So please remind that this is very important. And finally, for the recipe, for the last properties, and we know what is the reciprocal. Reciprocal, that means the fraction. So if we know that there is A, and the reciprocal should be 1/A. And so we can just follow some simple examples in here. 3 is greater than 2, but 1 over 2 is obviously greater than 1 over 3, and you know that is the answer. And for part B, also, if we can change the position, -5 is less than -4, but if we have the reciprocal, the size is changed. So please consider, pay more attention on the size. So you can think about that the inequality have something similar to the equation, but when we face on some calculation about the multiplication or the division, the size may change sometimes. So let's do some examples. If P is greater than Q, since you know 7 is a positive number, and you may know 7P is still greater than 7Q. And if M is less than N, since in part B there we multiply -2 on both sides, so we should change our position. And if you don't understand this, you can just put in some values. Okay, 2 is less than 3, but -4 is greater than -6. So just put in some values and you can understand the question. And okay, for part C, if A is greater than or equal to 6, we multiply a number on both sides and we have this answer. Since there is an equal sign here, okay, just give you a remark here. We have the equal signs in here. So after the calculation, we should keep the equal sign. So we should keep the greater than or equals to. And okay, for part D, since we try to multiply a positive number, as you can see, we can apply 3 in here. So for multiplying a positive number, we don't need to change the position of the arrows, the inequality size. So it should be this. And just give you some simple example. You know -9 is less than or equals to -7, and we multiply positive 3, the left hand side should be -27, and right hand side is -21. But you know the size still did not change. And okay, for part E, if we divide 4 on both sides, as you know, the answer should be still equal to the sign is remained unchanged. It should be this. And just give you some simple examples you may understand. Okay, you know 8 is less than 12. 8 over 4, that is 2. Still less than 3. And you will know the answer. And finally, for part F, since we need to divide -2 on both sides, so the size is changed. And okay, just give you examples for you to familiar more. Okay, if we know, okay, I just write down this -2 times 4, that is okay, or maybe I write in other way. Okay, -2 times -4. That is 8, and 8 is wrong examples. It should be better to write in -6. So you note -2 times -6, that is equals to greater than or equals to 10. Since for this part, this value is equals to 12. But if we divide -2 on both sides, the left-hand side still remains -6, and the right-hand side should be -5. But actually, you know, -6 is absolutely less than or equals to -5. So for the properties, we can plug in some values and try to check it is correct or not. And several concepts can make use of some proofs about the inequalities. So for part A and part B, the part A, I can give you the results first. Part A, this is correct, and for part B, this is not correct. And so, how can we do? So we can just have some basic ideas. Okay, I write down, use a black pen. The key is that for proving something correct, show your steps. So you can just think about this. It is some calculation, and you can base on the conditions in here and try to calculate, try to show your steps to the final answer. But for disproving, and what is disproving? That means show something wrong. If we want to show something is wrong, one important skill I should give you in here, that is give counter examples. So what is the counter examples? That means you should give some case to show the condition, the equation is not correct in the situation. So just give part A, and we know part A is something correct, and we can make use of the properties A is greater than B, and since if we multiply 3 on both sides, the size still do not change. And finally, when we add up this, and we know A is correct, so please write down A is correct. But for part B, as we know, the result is not correct. So we can base on the situation and try to give some counter example. So let A is equals to 3, B is equals to 2, since we can follow the conditions. That is the conditions. And for counter example, we can base on condition to try to plug in some value. So I just write down, or I use another pen, another color. Okay, I write here A is 3, B is 2, based on condition to put in value. And you know, for left hand side, -7 over 3, and that is -2 point something. And for right hand side, that is -7 over 2. So obviously, you know, this value is about -3.5, and this is 2.33, something like that. And you know, left hand side must be greater than right hand side. And okay, just write in here and so it is not correct. So actually, for this chapter, the concept is a little bit difficult for you, but just try to watch this video and get some basic information, and later on I will explain to you furthermore.